And this leads us really perfectly into sequence containers and what they can do. So in order to do that, let's actually take this footsteps random container that we've created, copy and paste. So we've duplicated it. Now we're going to rename this one footsteps R and this one footsteps L. And you may have noticed that our file names are named to match. So we're going to get rid of the L's in the R container and vice versa. And what we have now is left feet and right feet. And a reason to do this would be because we have now unique sounds for the left foot and the right foot. And you'll develop sort of a pattern. People will recognize the left foot versus the right foot sounds, and it'll just sound a little bit more natural than if we're triggering both feet from the same container. And this is where the sequence container comes into play, because rather than having the game trigger this one for every left foot step down and this one for every right foot step down, we're going to do that for them. So select both, hold down Shift, and now click the sequence container. We'll call this footsteps. Next, we'll just want to drag this contents editor up a little bit so that we can see what we're doing. And sequence containers, they don't function on their own like random containers. They need to be populated. So in order to populate the sequence container, we're going to click and drag the left into this playlist area on the right-hand side. Then we're going to do the same with the right. And so now when we trigger this top level sequence container, it's going to trigger one from the left, one from the right, and continuing on in that way. And it's starting to sound like footsteps already. So that's how a sequence container works. In a lot of ways, it's just like a random container, except that it needs to be populated in the playlist area, and it always plays in the sequence that you've populated it in. A few controls that you have are over here on the sequence side. You can choose to restart the playlist when you reach its end, or you can play in reverse order. And of course, if we're going to go into continuous mode, let's say you're playing a little 2D side scroller and your character's animation is constantly moving. Maybe you do want a continuous footstep pattern then. So let's just take a look at what that looks like. We'll select continuous. For starters, let's just hit play and see what happens. So that's not exactly what we're looking for, is it? And the first reason it doesn't function is because after 2 it stops. So we need to hit loop to have it play infinitely. Or we could select a number of loops, but obviously in this situation, we would just want an infinite loop. That sounds like this. And you may have noticed that there is a little bit of inconsistency in the speed between the footsteps. There's a few reasons for this. First of all, it might be that the audio assets are not exactly the same length. And second of all, even if they are the same length, there's going to be some differences in the length of each audio file because, as you may remember, we have created this pitch variation here, and changing the pitch of an audio file also changes its playback length. So we don't want that. We want a more consistent footstep, and that's where this transition box over here comes into play. So let's check that, and now we have a variety of options for how we want these transitions to happen. Now, crossfade, both amplitude and power, are for fading the sounds into one another. We definitely do not want that for our footsteps. Then we also have delay. Delay sets a time between the two objects playing. So this is still dependent on the playback length of the audio files because it starts counting this 1 second at the end of the one file and then starts playing the next file when that end of second is reached. And just for note, this can be a decimal point as well. There's also sample accurate, which triggers each new asset as soon as the previous one is finished playing. And then there's trigger rate, and that's what we want here. The difference between trigger rate and delay is that trigger rate defines the beginning point of the next playback asset, whereas delay starts counting at the end. So if we put 1, then one footstep will play every second. It sounds like this. So that's really slow. This is where that decimal point will come into play. Let's put 0.3. Give that a listen. It's too fast. That's pretty good. That's like a fast walk. So we'll go with that. Half a second trigger rate. And now we have our character footsteps. And this is essentially how a sequence container works. You can already see that stacking different kinds of containers allows for more dynamic functionality. And as you build these trees and hierarchies of various containers, you can create some pretty complex things. And we'll take a look at that in the next module.